Hi, my name is Daniel Salcedo,
And my name is Adolfo Arenas.
and today we're going to talk about an improved circular escape lift according to the paper. Let's start. This paper was made for Kuruksera University, and here they explain how circular escape lifts works. But first, what is a escape lift? It consists of multiple layers of linked lifts where each layer is a subset of the one below it, like a pyramid, that you can see. Improved circular escape lifts. So there are structures that consist in a circular linked list form in layers, like a conical way, with an improved predecessors. Its structure combines circular linked lists and escape lists to end search, insertion, and deletion operations. Okay, how works the searching in ICSL? Okay, the search begins at the top of the layer and process downwards and starts the search at higher level and moving down. The ICSL allows for efficient searches, and the advantage of that searching is that it uses the level of nodes based on the search frequency. Let's go with an example. Okay, we want to find the number 5 in that list. Okay, we begin to the head, go to the first node. We don't have the number 1. Only 1 is lowest than 5, but we go to the next one. 3 is lowest than 5, we go to the next one. Okay, and 7 is lowest, higher than 5, so we have to go back to 3 and then go down. We have number 3 again, so we have to go to the next node. Now we have 6. Oh, 6 is higher than 5, we have to go back again and down. Now we are in the lowest level layer of the structure, so there are all the elements in this data structure. Okay, we have to go to the next because 3 is lowest than 5 and 4 is lower than 5 again, so we have to go to the next node. Okay, finally we find number 5. How we search the number 5, this data structure is going to put the node in the up layer of this, so the number 5 is going to be here before the searchings. This way to search optimizing the search time in give up between data 1 and O log m. So it's very efficient compared with other similar data structures.
So guys, with the last method explained, we need to understand how the insertion method works in improved circular skip list, yeah, or ICSL. So the process is like a skip list insert method. We need to have an element to insert in our list, yeah. So in first we'll search this item in the list, yeah, this item in the list, like a skip list normally. So we look for the element in the first space where we don't find it. So we pass to the other space. We look for the item we don't find. So pass the lower space, and the element is not here. So when we say in the lowest space, we'll add the element to this space. This. Yeah. Why? Because 4 is little, more little than 5, but it's bigger than 3. Yeah. So if we don't find the element, we'll add it to the lower shape. Yeah. In this case, the lower shape is this. So next we'll take a random number to add the element from the end shape to the lowest shape. How is that? So a cool thing happen later. We'll use a random number, and with that number, we'll determine how many spaces will be occupied by the inserted item. For example, we put the 4 here, but we have a random number that in this case is 2. Yeah? Why? Because 0, because 1, because 2. Yeah. So our random number, I don't know, is 2. Could be 1, could be 0, but in this case it's 2. So we'll repeat the number 4 in the 0, 1, and 2 spaces. Why? Because we'll take the number and we'll put the number in the random number shape, in this case 2. And all the spaces under that number, yeah? So, in this case, the 4 is in the 1, in the 0, and in the 2 spaces. That way is how the insertion method works. Now, how's the deletion method works in ICSL? Well, just like a skip list method, yeah, it's too simple. And we have the item, in this case, is again 4, and we'll need to look for this item in all the lists, all the spaces in the list. So we look here, we look for here, here, and here. But we need to begin for the space in the top. So the 4 is here. Yeah, we begin in the heads jump to 3, and the 3 skip to 4. So we found the 4. If we find the element X, we'll unlink from the adjacent nodes. We'll delete this connection and this connection. Yeah, we'll delete this connection here and this connection here, and we'll reconnect the nodes to the adjacent elements. So the 3 will point to this and we'll continue to the head. And we'll repeat the process for all the elements 4 we'll find in all the lists. Yeah, until the list doesn't have any 4 element. And you can see the result here. The number 4 nodes are unlinked and the rest of the elements are linked. So at last, we need to determine that ICSL have a better searching by priority search method. What is that? Well, with a new algorithm that uses skip list searching method base, the most searched items will be upgraded to upper shapes. For example, imagine that we have a tree here, but in the first time we look for the tree, and the first we don't have the tree here, we don't have the tree here, we don't have the tree here. Yeah, we look for the tree and this is not, pass, this is not, and pass, this is not. So we'll go to the lower shape and this is the number 3. What happened? Yeah, how we look for the tree one time, the tree will be upgraded to the next shape at the top. This is not, and this is not. But the tree is now upper here. Yeah, if we look for the tree again, will happen the same. The tree will be here, and will be here. Why? Because in every search that we'll make for the same item, the item will be escalating for every shape until the item will be at the top. In this case, the number 3. So, conclusions. So let's see. Honestly, the authors did an excellent investigation and exposed this method in an understandable and simple way. The ICSL looks efficient and like a good way to find elements in a bidimensional collection. But that's all. The only original thing is the way to find something inside the list. And one of the worst things, a disadvantage with respect to a normal list, is that this research method only works with sorted lists. Pretty unversatile for normal situations where we could have disorganized information. But we don't forget that this method is efficient and the time is, yeah, is shorter.
Okay, now my conclusion and opinions about the paper. In the paper, every concept was really easy to understand, and the way to show us and explain how ICSL works using graphics, charts, every element was really good with every concept was easy to understand. Additionally, they give up the logic of every method like searching, insertion, and relation. So we have logic and we can repeat it in our projects. It's really good that. And I think that the improved circular skill lips is really everything because they have an O of log n, and when n is an element of the number of element of the list, and it's have that complexity in the insertion and the relation and in the searching. So it's really good and faster. Maybe I can get really well the code because it's a language that I can understand now. But maybe better. But I get the concept or I understood how every method works when I read the concept. So it's a good paper and now I want really good ideas to apply that that structure in my project. So that's it. Thanks.